let's get this started with the cartoon guide to physics. Now we're gonna split this book into two parts because it itself is split into two parts. And today we'll be talking about mechanics. Let's get this started with. Now, mechanics is an interesting thing about physics. In fact, you really need to start with motion. I've explained this so many times, I'm gonna try to run through it. Oh my god. Please ignore these red pimples. Now, firstly, there are a lot of motion that we can talk about. Now, first of all, Newton found out about mechanics by just throwing an apple up of the moon. Well, not in the moon, just an apple fell on his head and it was like, kerplunk. I didn't actually mean to do that. I meant to do this. Kerplunk. Seriously? Well, the next thing that seemed to happen is that he created the discovery that would have changed millions and millions of people's lives. The discovery of motions, gravity, and the laws of motion. Oh, sorry. Yeah, pretty much the three laws of motion, or whatever they call it. Newton's three laws, as they call it. And apparently that's all it seems to work out with. And then, of course, we start talking projectiles, because, like, we know that things fall down at the same rate. So what about if you, like, shoot something straight, and will they still fall at the same rate? Well, apparently, yes. It'll go like this. Like, start. This will go down. This will go like this. They'll fall. This horizontal movement has no effect on the vertical movement. Yeah, apparently that's true. And also, that's also the reason why you're weightless in on the top of when you're in space, because you're moving very fast that there's literally no gravity holding you. It's like you're in an elevator and so you cut the cable and then the elevator's falling faster. Not exactly faster, but you're falling at the same rate as the elevator. The elevator is bigger than you, so it stops first because, like, it's larger, so it has more. It's like more attracted to the ground more, so it hits first, and then you fall down. It will be like, cut, wee, bong, 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 accidentally kicks door open, wee. Yeah, that would be annoying. A way you can get in orbit, which this is also the reason why you can get in orbit, is that you go on Earth, wee, and then you fall faster then you can fall back down, so you're basically going in a circle orbit. And that's basically how perpetual motion also works, and that's also why you're in orbit. The next thing we're going to have to talk about is the four fundamental forces. Electromagnetism, the weak nuclear force, the strong nuclear force, and gravity. Now, gravity is not like these three forces. When this force, electromagnetism, can be split into two. Electricity and magnetism. Oh my gosh, should I do that? Electricity and magnetism. And with that, loads of things that can go ahead and be popped right up. In fact, electricity itself is just the creation. You can use electricity to create magnetism, and magnetism can be used to create electricity. That's a pretty fundamental thing, and a very fundamental discovery. And if this was discovered, that we can literally create anything, especially AC powered stuff, which is awesome. And then the next step that we're going to have to take is the fact that, well, yay, now what are we going to do with all this excess electrons? How about we use them to create an electric current? And then we have the current wars, and yeah, that's for electricity and magnetism. But let's go ahead and talk about the nuclear forces and gravity. Now, nuclear forces and gravity are two separate things. So let's start with nuclear forces. Now, nuclear forces is just the glues that put things together. It's like what makes quarks stick together to create protons and neutrons. And that's the strong nuclear force, the one that puts the quarks together. The weak nuclear force is the ones that put the protons and the neutrons together, and also the reason why electrons orbit around the nucleus of an atom, and which is how these bad boys are created. And then, of course, loads of things start happening. Collisions and rotation. Now, collisions are an interesting thing. Collisions are what makes fusion work out, and it's also the reason why fusion is awesome and how it seems to make more energy. However, we need right now of current technology, you need to put in more energy to create just this much energy. If you want to create this much energy, you have to use this much energy, which is not cost effective. And so we're going to have to look for cheaper ways to create it, like nuclear fission, for like another way. But to be honest, that's all about mechanics. The rest of all you need to know is the three forces. The three laws of motion, or like the first one is an object at rest will not move until like a force is acted upon it, and vice versa. The second law of motion basically says force equals mass times acceleration. Not gonna go into the details. And then the third one, it basically says Well, action has an opposite but equal reaction. Meaning action equals reaction. Like if you push hard on this side, it'll push at the same time. Like one side pushes, the other side pushes at the same amount of force. Which is kind of the only reason why you're standing up right now or sitting down. And that's pretty much all we have. This is a 5-minute video. It's just about mechanics, and there's so much more I can go ahead and talk about. But electricity and magnetism are the big deals here, so let's go there. See you guys soon. Out. Peace. Boo.